Yo, what's up, guys? So let's get going on this quiz 3 practice. So very first question here, it's just adding like terms. Just need to be careful with it. Be sure to distribute negative signs where appropriate. In this case, there are no negative signs to distribute, so maybe just rewrite it without the parentheses so it doesn't look so confusing. You don't necessarily need to do this, but it can definitely help. If there are questions that have parentheses to distribute, make sure you do so. Now we just need to add like terms. So this -8 and this -8 kind of come together to become -16. And this 5 and this -7 become -2 with the I on it. Make sure you're answering in that A plus BI format. You do need to have the real number first and the imaginary number second anytime you're writing these complex numbers. For number 2, the question is a foiling problem, kind of just like we've done before. So we simply distribute that 8 to both of them, distribute the 7 to both of them, and there's our first outer and our last. So we have 8 times -2 is -16. 8 times 8 is 64 with an I on it there. 7 times -2 is -14 with an I. And 7 times 8 is 56, and this one's got a nice squared because it's I times I. After that, we need to do a little bit of like terms and simplifying. Nothing happens with a 16 yet, but 64 minus 14 is 50. And 56 I squared. That I squared there, you got to remember that I squared is equal to -1. This is one of our key concepts that we're going to be using. So because that guy is equal to -1, this positive 56 I squared turns into a -56. Then we just got to add like terms. And again, make sure you write an A plus BI format. So we're going to write these guys first. That's going to be -72 plus 50I. One thing that's nice to do when questions are a little bit tougher, you probably didn't need a calculator for number 1, but on number 2, you can check your work using a calculator. So let me show you how you could do that. We would type it in exactly as it appears, 8 plus 7, and then to get the I, you need to use this I down here. It is on the period, it's the second button. So you're going to hit second I, that'll get you that guy here, multiplied by -2 plus 8, and then the I. Really good to practice doing the work, and it will again spit out that correct answer. Please note for the test, you must show that work here. I'm really looking to make sure that you know that this I squared is -1, that you're doing this work, but you are able to use your calculator to check your answer. Problem number 3. So in number 3, anytime you have a fraction with an I on it, you're going to need to multiply by the conjugate. That is to say, we have 1 plus 9i divided by 1 plus 9i, and it's the bottom, same exact thing with the opposite sign. So if this is a negative, it becomes a positive. If it was a positive, it becomes a negative. If the number in front, it stays the same. It's the second number that's changing. After that, it's kind of recommended to put parentheses around it. You don't necessarily have to. And then it's just like that previous problem, our first out and our last on the top. So we got -5. And then we got -45i. I'm not even going to draw them. They do the same thing with the 9 and the 9i. So plus 9i and then plus 81i squared. The bottom is where it's different. The whole point of multiplying by that conjugate, the a plus b times a minus b with the i's on them, is to get this trick where you're just going to square the first one and square the second one. No i's, nothing else, just like that. Then we just have to simplify it out. So simplifying it out is just like those previous questions. So we're going to have -5 there, -45, and +9 is going to become -36 with an I on it. And that +81 becomes a -81 with the I squared. And on the bottom, we get 1 plus 81, just squaring those two. Finally, adding our like terms, we're going to get -86 minus 36i divided by 82. However, we must write them as two separate fractions. So to write them as two separate fractions, we're going to write -86 over 82 minus 36 over 82 with an I on it. I think it's good habit to get into to reduce your fractions where appropriate. In this case, it does look like everything is divisible by 2. It's also a good chance. So I believe it's going to simplify to negative 43 over 41 minus 18 over 41i. But just to double check, we should always use a calculator. However, you need to be careful with a calculator. Let me show you what I mean. If you did what I taught you earlier in the year and use your alpha y equals enter, I'm going to show you that disasters occur with our calculator if we attempt it. Truth be told, this is a little bit of a waste of time to actually type this in, but just so you can see it, it was going to throw me an error. Well, I thought it was going to throw me an error. It's supposed to throw you an error. Maybe I updated this calculator and it fixed it, but what you're supposed to have to do is negative 5 plus 9 with an I on it, divided by 1 minus 9 with an I on it, and then hit division, and then hit math, enter, enter to fix it. So maybe it's also because it's like the color calculator. This is my sister's calculator, if you couldn't tell. Maybe her calculator is just fancier and I haven't used the fancy calculator before. Pretty nifty. Either way, this is our correct answer. Let's go to the back page. Number 4. Find the discriminant of each quadratic equation and state the number and type of solution. So the idea is we do need to find that discriminant. You can only find discriminants if it's already in ax squared plus bx plus c equals 0 form. So we do need to move this 7 over and this x over to make it negative 5x squared minus x. I said minus x and I wrote minus 1. Minus x minus 7 equal to 0. And then our a is going to be equal to negative 5, our b is negative 1, our c is negative 7. And the discriminant formula is that b squared minus 4ac is the part of the quadratic formula that's under the square root. So we got negative 1 quantity squared minus 4 multiplied by negative 5 multiplied by negative 7. And I highly recommend plugging all that into the calculator in a single step. If you plug it all in the calculator in one step, you'll have fewer chance of making errors, and it's just better off doing it this way. In this case, we get negative 139. So we have successfully found our discriminant. From our notes, we know that if it's a negative discriminant, that this immediately means that there are 2 imaginary answers, or imaginary. I like using the word roots because it has the fewest letters. 2 imaginary roots. So solve each equation with the quadratic formula or a different method of your choosing. If your answer is imaginary, remember to write in a plus bi form. So I'm kind of warning you there that at least one of these on the test is going to be an imaginary answer, and to be careful with it. So on this one, we're going to go ahead and take all this and we're going to throw it off to the left. We're going to take that 6 and subtract 6a squared minus 6a squared minus 9 minus 9. This 11a is kind of alone and just going to get thrown over here, becoming a positive 11. So we got 2a squared plus 11a, and then minus 30 is equal to 0. And because it says use the quadratic formula, that's what I'm going to do. However, this one might be factorable. Negative 60. This one definitely is factorable. So if you feel like factoring on questions like this, you can. But quadratic formula might be a good go-to. So we have a is equal to 2, b is equal to 11, c is equal to negative 30, and we are applying our negative b plus or minus square root b squared minus 4 a c all divided by 2a. And I again recommend, I started plugging in the numbers. I apologize. This is the formula you were using if you forgot your quadratic formula. I got ahead of myself and I'm going to have to rewrite this problem over there. All right. So B in this question was 11. So we're just going to change this to an 11. This is a really badly written 11. Okay. I apologize. Either way, we're going to plug it into our calculator all at the same step. Let's do it. So we have alpha y equal enter, and we have negative 11 plus, we got that square root of 11 squared minus 4 times 2 times negative 30, all divided by 2 times 2. We get 2 for one of our answers. And if we go and highlight this positive, change it to a negative, you get negative 15 over 2, and those are our 2 answers. Nice and easy with our quadratic formula. For number 6, same idea. I'm just going to switch colors to make it clear that I'm working on this new problem. We're going to move everything to the left-hand side, so we're going to have to add n squared there. So we're adding n squared there. We're going to add 5, kind of like this. So we're going to have 11n squared plus 5n plus 5 equal to 0. And again, a is equal to 11, b is equal to 5, c is equal to 5. On this one, I know in advance this one's going to give us an I answer. So if we put it into our calculator, it's just going to give us an error. So we're going to have to do a little bit more by hand. We're going to get negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And what I was talking about here is, oh, this is like a equals, oops. All right. What I was talking about is that this is going to give us a negative under the square root, because if I do just that discriminant part of the question, I will get a negative number. Specifically, if I plug all that in, I get negative 195. So what I have to do is I need to rewrite this like so. Negative 5 plus or minus our square root of negative 195 divided by 22. And that negative 195, anytime I have a square root of any kind that has a negative in it, so like square root of negative x, we simply make it the same exact thing with an I on the outside. So this one we're going to rewrite for our final answer, negative 5 over 22 plus or minus the square root of 195 over 22 with an I on the outside. That's pretty much it. That's the whole video. Have a wonderful rest of your day and good luck on this quiz.